Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to get you and your students prepared for the upcoming AP Calculus exam. My name is Mike Houston, and I'm the moderator for this event. I teach AP Calculus and Statistics near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. And with us tonight, we're joined by two experts, Vicki Carter and Tony Record. Vicki recently retired after teaching high school math for 46 years at West Florence High School. She's a former co-chair of the AP Calculus Development Committee, served as an exam leader at the AP Calculus reading in the summer of 2022. She's received the TQ Leadership Award. She's served on many TI-Nspire authoring teams. She's really done a lot and been around for a very long time and done lots of presenting. So, Vicki, we're really excited to have you with us tonight.
Thank you. I'm really happy to be here and get to share some resources and review ideas with everybody.
And Tony has been a math teacher at Avon High School, a suburb of Indianapolis, for the past 33 years. For the past 23, Tony has primarily taught AP Calculus and worked to build his school's AP Calculus program to nearly 300 students now. In addition to being a TQ'd regional instructor, Tony is active with consulting with the College Board and having produced several AP Live and AP Daily lessons, as well as trained teachers in 27 states. He's authored the AP Calculus AB curriculum for the KIPP chapter school system across the U.S., has written several test prep materials for various print and online publishers, such as Propel Enterprises and Get5.com. He serves as an AP Calculus consultant and question leader for the College Board. And again, in Avon, he lives with his wife and two teenage children. And in his spare time, he loves to play guitar and is active with Central Indiana's Hendricks Civic Theater, having appeared in several productions. So, Tony, I'm not sure when you have time for that, but that's great that you're able to do that. Thanks for joining us tonight.
You know, my wife asks the same question sometimes. It's great to be with everybody this evening. And hopefully, along with Vicki, we're just so excited to share some things that we hope you find pretty cool. We're definitely thrilled to kind of get down to the nitty-gritty and start thinking about how we're going to review for the AP exam.
Thanks. And Tony, will you just keep it going and talk through our agenda for tonight?
Certainly. Obviously, one of the biggest focus of tonight is going to talk about what calculator skills do our students need to know so that they can apply them towards the AP exam on those few questions that are going to require them. And it's not a situation where it's too late if you don't feel like you've done a good job this year of instilling those skills. You've still got plenty of time, and hopefully you can take some of those strategies away with us tonight. We are going to use both the TI-84 and the Nspire to practice these four main skills that we're going to focus on. We have two brand new Mixed 6 that we're going to share with you. If you're not sure what a Mixed 6 is, stick around. We're going to talk a little bit more about those. And we have a wonderful circuit that could serve as a great review for the use of the calculator in AP Calculus. Several examples of some calculator active FRQs that we're going to share, and rumor has it there could be a webinar drawing at the end, so stick around.
Tony, thanks so much. And Vicki, will you talk through our expected outcomes for tonight?
So we hope the first thing you take away is feeling a little more confident about how to use your calculator in the classroom and make sure your students know exactly what they'll be expected to do with the calculator on the AP exam. Show you some resources and how you can find those resources, and actually see a little bit. We're not going to do much with the multiple choice questions because the Mixed 6 and the circuit kind of cover what a multiple choice type question would look like, but we're definitely going to spend some time on some recent free response questions.
Awesome. Super exciting. We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Tony or Vicki using the Q&A window on the right side of your screen. We'll also be using that chat window tonight to send general messages, and actually let's get right to it. And I kind of want to see really who's on with us tonight. So if you are an 84 user, if you could just type 84 in the chat window and send that. If you're an Nspire user, just maybe type an N. And if you use both, maybe just type a B. So 84 for 84 user, N for Nspire, and B for both. Just kind of give us a quick snapshot of maybe who's with us tonight, what we should or shouldn't focus on, depending on who's here. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. All right, so with all those responses pouring in, thanks so much, everyone. Tony, I've given you control. Feel free to share your screen. Looks good.
Okay, so there are email addresses, and of course the title of this is Let's Get Prepared for the AP Calculus exam. This will be recorded, so if you need to go back and look at those later, that would be fine, and you would be able to find them there. Okay, so what are the 4 calculator skills? There is a URL there, which I am going to copy and put in the chat real quick. It will give you a lot more information than we actually are going to discuss here about how to use the calculator and what the students are expected to be able to do. But basically, as an AP Calculus teacher, we think of 4 things that a student should be able to do with their calculator. The first is they should be able to plot the graph of a function. They may have to manipulate the window a little bit, especially if it's a contextual problem, in order for it to fit the context that is implied by the problem. They should then be able to use that graph to find the zeros of a function, and that sort of is implied that they would also need to maybe be able to solve, like find an intersection point of 2 equations, because as we all know, there's a way to make that into a zero of a function problem if necessary. So those are sort of pre-calculus skills. They're coming in from Algebra 2 and pre-calculus, but then the 2 big ones that actually are our calculus skills are numerically calculate a derivative at a point, not find a derivative, but find an actual slope of a tangent line, derivative at a point, and to approximate the value of a definite integral. So those are our big things that we need to make sure our students can do for the AP exam.
Okay. So thinking about from a strategic perspective, what are the strategies for using the calculator? Well, ideally, we would like for all the teachers across America and beyond to use the calculator as quickly as possible, really, to implement it as soon as you can. And I know that that might go against the grain, how some teachers are a little bit more kind of hesitant to say, well, I don't want my students to be too dependent on the calculator. But the thing about it is you have the power as a teacher. You can always control how you assess your students, allowing them to use the calculator and allowing them to not use the calculator. And I know that I can speak for Vicki in our classrooms throughout the years that we've taught. That's pretty much been our mantra since day one, because we know that the students are going to take an assessment that at the end of the year is going to be half with calculator, half without, or approximately. And so we want to establish that pattern very, very quickly. So what are the kinds of things that we could do as early as the first or second day of class? Well, obviously using the calculator to make a table of function values to estimate a limit. It's probably the first thing that my students do in my classroom after they turn that machine on. Later on, we start talking a little bit about the derivative and how the derivative is just this wonderfully amazing way to kind of like peek through a microscope, and how you can zoom in on a curve repeatedly and see that the thing is actually just linear. One of my favorite TI-Nspire activities, A Tale of Two Lines, does such a good job of explaining how L'Hopital's rule works with that very same kind of philosophy. Of course, as we move deeper into the course, a great way to visualize these representations of Riemann sums. Back in the old days, some of you might know what I'm talking about. You know, we had to draw that curve and draw those rectangular strips and cap them off on the left side and the right side and kind of explain that that's what a Riemann sum looks like. And it took a long time to draw those. And now we could use the technology to render one of those graphs very, very quickly and start having some great conversations. And of course, creating slope fields to investigate the solutions to differential equations. Both the TI-84 and the TI-Nspire do such a great job. So while these things specifically aren't among those 4 specific skills that a student would use on the day of the test, these are great things that a student can use their calculator for to help gather a better understanding, and they can certainly foster some great, great discussions in your classroom. So resources to review and use the calculator. Well, what are we going to show or share with you guys later on today? Well, Vicky, she's retired, but I think she's now kind of like the Energizer Bunny. She's been developing so much great content now that she's got a little bit more time. And some of these things are just right off the press within the past few days. And so we're going to share some of these mixed sixes. One of them is going to be about finding a derivative at a point. Vicky will talk about that. We also have a mixed six that I'll explain a little bit about approximating a definite integral, kind of focuses on that one skill set. And then we've got that great circuit review that you could implement somewhere around the month of April to get your students really kind of acclimated to these skills and do so in a circuit environment so that it's very self-checking. So we're all excited to share those with you.
Okay, so what is a mixed six? Where, how, why? Where did this come from? So back summer before last, I had read Peter Liljedahl's book, and I don't say that very well. And the things that really struck me about what he was talking about in the book, as far as things to do in your classroom to build a thinking classroom in mathematics, were the vertical non-permanent surfaces, random grouping, like all the time, random grouping, and thinking task. And there are a lot of other strategies, but those three really hit me. And so I was trying to implement some of this in my classroom during my last year of teaching. Yes, I know, year 46, here I am creating stuff that is a once and done almost, but hopefully I was sharing it with other people to use. I started thinking about what I needed to do for reviewing my students for the AP Calculus exam. So this is probably about March of last year. And I just happened to go, and I do this about once in it's probably once in a blue moon, to be honest with you, but I jumped on Twitter to kind of check out some professional things that I follow, see if there was anything interesting there. And I saw a post by a gentleman named Ben Gordon, who is from England, and he had a Google Drive that he was sharing that was full of middle school level mixed six activities. And I started reading about it, and I was absolutely blown away. So I decided to try my hand at writing one, and I guess the rest is history. At this point. So you're going to see what one looks like in just a few minutes.
And sort of the philosophy, at least the way that Vicky and I see from a Mix Six perspective, is that it's sort of a recapitulation of Bloom's taxonomy, right? We as educators have been through that, educational psychology class. And if you had a chance to check out, Vicky and I had a webinar back in the fall with the Mix Six. We're going to also follow that up with another very in-depth sort of probe into the Mix Six activities later on in May, so stick around for that. It appeals to everyone from Algebra 1 all the way up to calculus and all parts in between. But we probably remember those, well, maybe we remember, right, those six hierarchical skill sets on Bloom's taxonomy. I won't read them all here to you, but it just seemed that, yes, six pieces or six steps of the Bloom's taxonomy, six boxes in the Mix Six. It's not a perfect one-to-one alignment, but we feel like it comes pretty close to sort of bin pack the way that you see there on the screen. And like I said, we're going to get into a little bit more detail with the Mix Six in a moment, and then we'll do a deep dive later on in May.
Okay, so when Tony and I were going to do this webinar, I decided that I wanted to write one because it helps me think about what I want to basically tell you, what I want to share with you. So I wrote a mix six for the finding a derivative at a point, and then Tony's going to go over the one with the definite integral. All these resources are in the resource folder that you will have access to, and we're going to show you another place that you can have access to them. So when we look at these different little strategies like factual recall, well, this isn't exactly a factual recall, but this is can I pick my calculator up and remember just how to press the buttons to get that? So I do call that sort of a factual recall of technology. And then let's continue that theme with another question where we actually want to apply that. So our students should know that the slope of a tangent line is found via the derivative at a point. And so let's see if we can use that language of slope of a tangent line and then find the derivative at that particular value of x, and then continue that to write the equation of the tangent line. The classify was a little bit interesting for me. I wasn't too sure exactly how to input or how to work this one out with this calculator use, but I decided one of the things students have a lot of trouble with is they're given a derivative and then they've got to identify using the first derivative test where they might have relative mins or relative maxes. So I thought this might be a good place to put that, where they're actually just sort of identifying and classifying those relative mins and maxes. And then I wanted to kind of semi throw a little contextual stuff in here. And so we call it contextual light when we do particle motion. But show me that you can tell me by using the calculator that the particle's slowing down. And then I have a little rate. Those are very popular on the AP exam. And then my all-time favorite, and these are so much fun to write, because all you have to do is think about what's that common error that students make all the time when they're doing things in calculus. So that's critique of fallacy. And so you basically present a problem that someone has done incorrectly and tell me what they did wrong. Correct it. And so it's just a lot of fun to do these. We're going to take a closer look at a couple of these and actually how we would implement the calculator to do them. So let's start with that factual recall. Find a derivative. Tried to make it a little bit complicated, not too complicated, but a little bit of a skill set in entering these functions into the calculator. So if you're on the TI-84, you would go to Math, and then you want the derivative at a point, that's number 8, and you get a template. And then you want to input basically what you see. So it's going to be your function that's in the first set of parentheses, and then after the such that, the vertical bar there, you would put your x, and then you would put your 0.6, and you would have your solution. We're going to look at the same problem with the TI-Nspire. So in this case, you would have a calculator app open on the TI-Nspire. You probably can guess we're going to go to calculus. And I was using the new online calculator, which is not CAS, which is probably good to show everybody, because sometimes the students do need to go to this numeric derivative at a point, even if they're on the CAS version of the TI-Nspire, but they're going to find the numerical derivative at a point. They get a little template to fill in, so their variable in this case would be x, the value at which you want the derivative, 0.6. We want a first derivative. They do have an option to change that, and then press OK, and then all they would need to do at that point is input the function. And I did not store this function because I was only going to, it was a use it once and I'm done with it. So it was just as easy to type it in inside the parentheses for the derivative and get the same result that we got on the 84. So this again is a problem that students have a lot of difficulty with. I don't think they think quite the way they need to, because they think they've got this function and they're just not too sure what to do with it. But in this case, we want them to find the x-intercepts only of the graph of h prime. So this is sort of a, let's get our foot in the door. So maybe that's a hint. So they're going to graph this h prime, find the x-intercepts, and then look at what that graph of the derivative is doing to determine the locations of the relative extrema. And so here's the graph. I have already calculated the x-intercepts, and they're showing there on the graphing screen. And so we see them, put little circles around them like a little magnifying glass. There they are. So what's happening? Well, at this first one, at x equals 0, the derivative is not changing sign. It's negative on the left, it's negative on the right, so that is neither a max nor a min. At the second one, 1.319, our derivative is changing from negative to positive, therefore we have a relative min. And at the third one, our derivative is changing from positive to negative, so we have a relative max. So when we share a folder with you in just a few minutes, as I said, these are also in the folder, the resource folder that you're going to get. Not only will you have the copy that you were just looking at, which is sort of what I call the student version, you also will have a answer key. And here I tried to put a few things in. For instance, in the first one, use the tool derivative at a point on your calculator to give you some insights on what to do. We hope that these answers will help you along the way and help your students if you feel like you need to share them with the students. They're free to use. They're yours. Anybody, if you want to edit it, change it, it's fine. In most cases, we have both a Word and a PDF document of both the student version and the answer key. So have fun.
And I went ahead and put a link in the chat for the folder with the resources for what we're talking about this evening. And then Vicki and I have got a few other links that we're going to share to you that have a broader array of resources for the Mix 6 and some of the things that I've shared with the Dropbox. And don't worry about if you're like scrambling through the chat to find those links. I know sometimes that can be really frustrating. We'll make sure that we put one more big post at the end of the chat, as long as somebody reminds me to do that. And that way you can click on those links if you happen to miss them before you guys exit the webinar this evening. So I'm just going to talk briefly about Vicki's using technology with integrals, because, you know, obviously that's the second branch of the calculus tree, at least from an advanced placement standpoint in AB. And so we're going to take a look at, I believe, the factual recall in this particular problem, which is evaluating a definite integral. And yeah, a lot of times on the AP exam, it's very likely that this is going to be a little bit more, shall we say, robust, right? Where we wouldn't really want to do this particular problem without the use of a calculator. This would be awfully tough to do for an AB student for sure anyway. But in any event, we're going to use technology to make that happen. And really quickly before I do that, if you guys want to take another couple of looks at a few of these other boxes, Vicki's got some really neat, rich questions in this particular Mix 6. So be sure to take a look at this one, download it, and use it with your students. So we are going to look at the factual recall. And so using both models of the calculator, we'll share our TI-84 first. Everything starts with that math menu. This time we're going to go to option 9. I think a lot of your kids just kind of memorize math 8 for a derivative, math 9 for an integral. It always works. And so they're going to get this nice, pretty template as long as they have a fairly newer version of the TI-84CE, of course, and one of the newer operating system upgrades from the previous family of TI-84s. And then we just basically enter the function just the way that it appears in the integrand there with the correct boundaries. We're going to
And
always
Tony,
use.
I just noticed I've got an error there. So the
Oh my gosh,
2.4 is
you know,
missing.
the answer, multiply by 2.4,
Yeah, there
right?
you
That's
go.
what that's the test today. So yeah, I bet the answer is going to be 2.4 times that 3.2.
I believe
But
it
in
will
any
be.
event, that's fine. We always find them here at the last second. But in any event, a very easy tool, right? A very math 9, it's so accessible for the students. And you know, in some ways the students think, gosh, I'm allowed to do that on the AP exam. You're not only allowed to do it, you kind of are expected to do it in a couple of spots. So if we take a look at the TI-Nspire approach, obviously everything begins with that menu, and we end up going into that calculus option, where the option here is going to be numerical integral. Those of you who are using the handheld, you might be a little bit aware of the shortcut Shift plus and Shift minus. Oh, such a great pair of shortcuts on the Nspire. And then again, it's going to produce a template that, to be honest, looks very similar to the one that we saw on the TI-84, of course. And then we just very carefully enter it correctly this time, right? Correctly. And then we will get our answer that is 7.69 there. So there we go. Shift minus and Shift plus. Yeah, great ways to end up getting your shortcuts for derivatives and integrals.
So somebody
trying to
has
think.
I don't know if they're asking or they're amazed. Shift
Yeah, I
plus.
didn't know if I said it wrong there for a second, but yeah, shift
Well,
minus.
okay, so shift minus is a derivative because a derivative is the limit of a difference quotient, and shift plus is your definite integral because you're doing a summation with integration. So
Yeah, it's a great way to remember it. Yeah, exactly. So, and then I always try to think, I'm talking about this one, right? Yes, this is the answer key here to that using technology with integrals. So everything that we provide for you is going to have a very nice detailed solution key so that you don't have to worry about working through these on your own. And you can really get a good feel for really where it's going before you administer it to your students. So I guess the next question is, where can we find a collection of these mixed six activities, right, Vicki? Right?
that's right.
Where can you find this? So right here is a link. I'll drop this one in if you don't mind,
Oh,
Vicki,
I've got it
into the
all right
chat.
now. I just pasted
Okay,
it in. Okay.
there you go. So again, if you want to click some of these on the fly, uh, we're kind of worried that we might lose you for the rest of the evening, right? But you can certainly click on those links, just open up a new browser, and then you can always save those later on and organize them as you will. But again, we're going to make sure that you get these links all at the end of the webinar so you guys don't have to move screens around and so forth. But we're going to talk a lot more about mixed sixes later on in the month of May. So stick around for that particular webinar and talk to your friends, your Algebra 1 friends, your Geometry and your Algebra 2 friends, because that's when the whole math family gets back together, right? We're just calculus teachers tonight, but we're going to get the whole group of us back together at the end of the year. All right, Vicki.
Okay, so several years ago, I realized that students still struggled with they knew how to find a derivative. They knew how to use their calculator. What they didn't always understand is, well, when do I do what? I don't know whether I'm supposed to be doing a derivative or an integral, or I just don't know what I'm supposed to do. If you'll just tell me, I can do it. And the same is true even with the non-calculator questions. If they knew what to do, they typically could perform the process. So I wrote this circuit, and if you're not familiar with what a circuit does, I kind of describe it as a scavenger hunt for an individual. So instead of having students go around the room with problems posted and they get the answer to this one and then they have to go find the answer to the other one, this is sort of a little individual scavenger hunt. It works really, really well. Verge Cornelius, Nancy Stevenson were kind of the two that started this little trend of making circuits. But this one, I wrote it, but a lot of people like it, think it really do think it helps the students right before the AP exam just kind of get, some good practice with when to do what on their calculator. So if you're not too sure what goes on in a circuit, you basically look at the very first question that's on the upper left, and it's already labeled number 1. You ignore the answer because what's going to happen is that's going to be the answer to the very last question. And if you don't come back to that one, something went astray as you were working your circuit. So the first question is, what is the slope of the line tangent to this function? So as we just said a few minutes ago, hopefully the students will say, aha, this is when I need to find a derivative. So they would find on their calculator, because this is a practice of using the calculator, and I just did a screenshot from the Nspire since they're very similar as far as what's going to happen. So they compute this derivative on their calculator, derivative at a point, and then they go search for that answer. So Tony, you'll click a button, I think it'll go back to the big circuit. And if you look around, you will find it at click one more time, Tony. I think something pops up. It's supposed to. There it is. So there's our answer. So it happens to be at the bottom right on the first page. So that you put in where the number symbol is, you make this problem number 2. And now you would work this question. Notice that I jumped straight from a derivative to an integral because now we want to find an area enclosed by 2 different functions. Hopefully the students will graph those 2 functions, they will look at their intersection points, and then they will correctly input the integrand and the intersection points on their calculator and actually find the area enclosed. And then you sort of continue that way. You should answer all the questions and go back when you get to the very last one. By the way, that's a screenshot. And if you notice, those X coordinates were stored. I stored the first one, -3.443 is A, and the second one as B, the 0.889, so that I didn't have to use a lot more think about more decimal places. I can retain the accuracy by having them stored, and then all I have to do is type in the a and the b on my definite integral and reference the f1 and f2 functions that I had put in to see the graph there. And you just sort of continue this way. Like I said, it kind of bounces back and forth from derivatives to integrals, and there's some contextual problems there. There's a volume. There's just some different things to try to make them think of different ways they might have to use their calculator and the kind of question that might prompt them on the particular use of the calculator.
All right. So you've got some more review suggestions, things that you could think about implementing if you don't already do these in your classroom, especially as you finish up. It's such a wonderful feeling when we were able to finish up, teaching all of the curriculum in the course and exam description. And then, sometimes we look at our watch and we have like a whole month or month and a half to review. That's the perfect scenario. But a lot of times, especially post-COVID, it's a little bit hard to get that many weeks of review in. And so sometimes we're like, oh my gosh, maybe I only have 10 days, 2 weeks. But there's always ways that you can make the most of all of those days that you have. A lot of teachers, we use this idea of multiple choice Monday. It's got the nice alliteration with it. And so you can start the day Monday with some multiple choice questions that you can find from very reliable resources, whether they're AP Classroom, maybe they're going to be on potentially they could be on some of the secure exams that you are certainly allowed to use with your students in face-to-face settings. The secure exams that we talk about are what was known as the international practice exam. Those are the exams that were administered outside of North America on that same testing day to avoid, time zone discrepancies and students communicating and whatnot. Free Response Friday, there's the alliteration again. You can announce a topic at the beginning of the week. Students can start thinking about that on Friday. Students work in pairs on a recent FRQ. I call this Free Response Roundup. I'm going to share that activity here with you later this evening. And I'm also going to share a way that you can find all of the free response questions of like types, like all of your rate in and rate out problems, I have retyped for all of you, and you can get them in one document and with the solutions and the scoring rubric with them, and so that you don't have to filter through so many different tests to come up with all those problems. And I have them liked in kind of grouped, I should say, in about 10 different categories that I'm going to share with you. And then, of course, we have a new use of a Mix 6. Dennis Wilson's another T-Cubed instructor from Georgia. It does some fantastic work with many subjects, calculus just being one of them. But we've got this really wonderful motion review that he just shared with us not too terribly long ago. So we wanted to make sure that we gave Dennis a shout out, but we also wanted to share this with you as well, because basically the Mix 6s, they don't have to stop, right? We're finding each week that goes by, more of these are being written by teachers like you across the country, shared in this Dropbox that we're going to make sure that we give you guys access to, so that you can use these with your students and maybe write some of them your own and share them with people across the country as well. So that's what we're kind of excited about. Right here,
So,
Vicki, I think this is you. Yep.
okay, yeah. So I wrote that Mix 6. Actually, Dennis shared one with me, and I was so impressed with it that I decided to try. That's fine. I decided to try my hand at doing one because I just absolutely love the idea. So he had written one on my own modeling based on I think a 2019 Calculator Active free response question, and you can find it in that Mix 6 folder that we have already shared with you, so it's there. Um, So I decided to try one on particle motion, and I had remembered that in 2019 the students had a little trouble with this one because we were talking about two different particles. One particle was presented in a tabular form and the other particle was presented in an analytical form in part C, and they were like confusing everything. So I thought, okay, I'm going to try what Dennis did. So the idea would be to give the students the mix 6 on maybe early in the week, see what they did with it, and then give them this free response question to see if their ideas have been, gelled a little bit. They've got a better grip on what they need to do. So to give you an idea, with that mix 6, the number 4 question actually matches really well with part A, and the number 2 question matches really well with part B. I think I asked them to do a right Riemann as opposed to a trapezoid. I mean, I didn't want it to be exactly like what they were going to do, but hopefully thinking about a Riemann sum would trigger their memories with the various types of summation processes they needed to do to approximate area under the curve. Um, part C is a little combination of both 1 and 5. And then part D is, can't remember. Oh, it's coming from 6. That's where I did my critique of fallacy. I am going to have to tell on Tony real quick. So when we started writing some mix 6, he said, Vicki, I started using my phone and I occasionally take pictures of students' work when they do something wrong because I want to remember it. And I loved it. I loved it. But usually you can think of, like I said, classic things that students do and find a fun way to incorporate it into that number 6 critique of fallacy. And my grandchildren's names have started being on the number 6 question now. So
Yeah. Kids, our students just begs, don't put our names on it though, right? Don't put our names, but
believe
just
it
your
or not,
birthday.
mine begged to have their names on it. So,
Well, yeah, there you go. And pictures, right? We'll put their pictures on it as well. So you guys have now started to see some actual AP free response questions, right? Vicki shared one from 2019. This is one that might resonate well with you if if you taught AP Calculus at least last year. This was problem number 1, ABBC1, our very often rate in, rate out problem that tends to lead off the AP exam. I'm not making any guarantees, but in the recent years, that has been problem 1. But what I wanted to show you here is a breakdown of where are those calculator skills being implemented on this particular problem. So I don't want to read the whole question in its entirety, but you might remember that this was the rate at which vehicles were arriving at the toll plaza. We were given this pretty nasty looking function A of t, and then some time elements. And then we were asked 4 different questions. Well, I want you to take a look at part B. Find the average value of this rate in vehicles per hour at which the vehicles arrive at the toll plaza from time 1 to time 5. Well, lo and behold, that happens to be skill number 4, numerically calculate the value of a definite integral. So these skills are not hard to see very often in these particular problems. Now, obviously, finding the average value, that has a separate element, topic 8.1 of the course and exam description, although a lot of teachers do teach average value of a function way back when they start teaching fundamental theorem. Totally okay. In fact, this is the lesson that I am teaching to my students tomorrow when I return to my school in 8.1. So what else do we have here? We've got part C. Is the rate at which the vehicle's arriving increasing or decreasing? Well, because we're looking at the rate, which is the function A of t, and determining its increasing or decreasing behavior, another derivative has to enter the picture. And so we are going to numerically calculate the derivative of this function A of t, and that will give us the answer. And then we might have to do a little bit of justification, give a little bit of reasoning using some words. Yes, kids have to write a little bit on the AP Calc exam. They have to be able to communicate. And we'll have to determine whether or not we have an increase or decrease based on the sign of our derivative. And then if you look at part D, the little wordy question, a line forms whenever A of t is greater than or equal to 400. The number of vehicles in line at that time is given by this function defined by an integral. right? It's sort of the integral as an accumulator. And we know that A would be the time when the first line begins to form. Well, to the nearest whole number, find the greatest number of vehicles in line at the toll plaza. These often are really challenging problems because this is going to be what we refer to as the extreme value theorem or the candidates test. And so there's a lot of moving parts going on with this, but as you can see, this particular problem is certainly going to require finding some zeros of a function so that we can solve solve this numerically. And I think we've got time just really quickly. I was going to share some screenshots here as long as the technology will cooperate here with me. But I'm going to share the TI-Nspire here just for a moment and talk about those elements of this particular question. For those of you that are Nspire users, I'm actually using a notes page, so that way I can kind of write this nice text that describes what I'm doing. And everything that you see here in blue and green would be in a math box. I don't typically use this or teach from a math box and a notes page. I know a lot of teachers do with wonderful results, but I find that this makes a better presentation tool. But basically, what you're going to want to do with this is you're going to have to make sure that you get your kids on board with the fact that if they define the function in the calculator, whether it's the TI-84, which I'll share with you in a moment, or the Nspire, it's going to save valuable minutes later on, and it could potentially allow much less of a chance to enter something incorrectly. So all I did here is I just typed in my A of T. To get that colon there, I'm just going to show you here the keystrokes. It's Control Math Template. There's several ways to do it, but that's the colon equal that will define the function. And then as soon as you hit enter, the calculator will say done, which is like, done, what did you do, right? Well, it stored that particular function. And I believe it or not, I don't tell my students to check whether or not the function was entered correctly. I don't even tell them to double check. I tell them to triple check. And I really mean that. I want their eyes going from the page to the calculator screen no less than 3 times to make sure that they have every piece entered correctly, because it could be disastrous. Otherwise, they could only get points for setups, and all of those answers just wouldn't make any sense. And so students are generally pretty good about that. And of course, once that is entered, we just simply go into our wonderful shortcut. If you remember on the TI-Nspire, Shift plus, yep, that's what's going to give you that definite integral template. You could, of course, put your 1/4 in front and then proceed like Vicki and I had mentioned earlier. How about a little TI-84 love with the same question? Of course, you can define the function on the TI-84. You're going to do that in the Y equal menu. Even if you don't graph these particular functions, a lot of people think, especially new users of the 84 think, well, there's no point of putting anything into the Y equal menu if I'm not going to graph it. I never did once graph this particular function when I solved this problem. But by defining it here in the Y1 menu, now, of course, you're going to have to use the variable X instead of T. That's not a problem. Your students are going to be okay with that. They're used to using X with the Nspire. And then we go to the quit second mode, we go to the calculation page here. And then again, to get this really quick shortcut here, well, of course, the fraction could be alpha y equal. A couple of other ways that you can get that fraction, of course. And then the magical shortcut for the TI-84 is math 9, right? 2 keystrokes, math 9 on the 84, shift plus on the TI-Nspire. And so again, you would just enter your values 1 to 5 for your boundaries of integration. And I just wanted to go through real quickly, how do we call up that Y1? There's several different ways to do it. I'm only going to share one. And for homework tonight, you guys can find the others. Alpha trace typically is going to do a good job of bringing up the other contextual menus here. This one happens to be the Y vars, and of course, Y1 is the one that we want. And why not? Let's just finish this off, huh? And of course, I hope it gets the same answer, and it does. So if I return back to the Nspire here, just real briefly. I don't want to spend a lot of time going on with each of these because we've got a few other things that we want to share with you. But in part C of that problem, I'm not so sure if we even remember part C. I think I've forgotten part C. So no big deal. We'll go back and we'll read part C. Is the rate at which the vehicles arrive increasing or decreasing? Let's give a reason for the answer. And so what we're going to have to do there, as I talked about before, is we're going to have to take the derivative of that function a of t. All right, so you're just talking about going shift minus on the TI-Nspire. You would be going math 8 on the TI-84. And in both cases, you're going to evaluate it at 1. And of course, we have this positive number, which is so revealing. And of course, we would have to have some justification that could be worded a little differently, but along the lines of saying that a prime of 1 is greater than 0, the rate at which the vehicles arrive at the toll plaza is increasing. For whatever it's worth for you TI-Nspire users, don't worry so much about this, but the TI-Nspire doesn't do a great job of case insensitivity, or is it case sensitivity? In other words, if you
It
type
doesn't care.
capital, it doesn't care. There we go. If you type in capital A, it looks beautiful there for a while here, but as soon as you hit enter or leave the screen or go back, it's going to revert to a lowercase a. Now down here, this is just text that I'm typing in, so you can do pretty much anything there with capital letters and lowercase letters. But again, on the TI-84, it's the same kind of interface. Remember, you've got that function a already stored as y1. And so you can just hit your math 8 and then you're right on your way. And then if I were to look back at the problem, I think there is a part D. Just not to go into great detail with this, but this one's got a couple of other types of steps that you'd have to do. This one was worth a few more points on the exam. In fact, if you give me 2 seconds, I can tell you this problem was worth 4 points out of the total 9. So there's a lot of things that are going on here. And so the first thing that we have to do is, if we're going to figure out the greatest number of vehicles, where the number of vehicles is n, we're going to have to take the derivative of that n. And that's not a terribly difficult task. It doesn't require the calculator because we're just using the fundamental theorem, part 1 or part 2, depending on what your book says. They're all a little different, but we essentially just plug this t in for that x, and we do away with the integral altogether, and we have a of t minus 400. Well, what do we do with that a of t minus 400, you might ask? Well, we are going to need to set it equal to 0, right? And so we're going to solve that equation, and we're going to do so by graphing. Yes, we know that there are wonderful CAS machines out there. You could probably take a of t minus 400, set it equal to 0, and it might work. But I have encountered some problems on some of those international practice exams where they are written so that CAS users don't have an advantage. And I frankly tell my students who use the TI-Nspire CAS to go to the graph first. Besides, you get a much more, vivid representation of what's going on. So as Vicky kind of showed you earlier, you would just sketch this graph and you would find those points of intersection. I did that by just going into the, make sure I'm in the right menu here, make sure I'm in the right window. I go into the menu and it's analyze graph and then option 1, zeros. And then once I find those, it's very easy to store these on the Nspire. You just click on the, or you highlight, I should say, and then you can hit the var button to store that particular boundary. And then once we have those in the calculator, then you could do a variety of things. It's not 100% necessary that a student has to set it up like this. It's kind of nice that you can see all of the action happening, but I just stored the function n of t the way that it appears right off the page, pretty much word for word, symbol for symbol. The only exception is that I had to use a dummy variable of x right here, and I used the upper boundary of t, and then I knew that x1 was the first time that the line began to form, right? It was the first time that that graph was able to have an x-intercept. And then I just simply calculate each of these one at a time, and I come up with the answers. And then from here, it's pretty easy to see that 71 would be the maximum there. You do something very, very similar on the TI-84, but what you're probably looking at there is just simply typing this expression in one time, right? Using the boundaries that were given to you. The X1 would be that first particular intersection point that we had on this screen, which is the 1.494, right? And then the upper boundary is either going to be that 0.494 or the second time that we had that intersection, 3.5, or 4, because if you remember, if we look back at the problem, which I promise I will just switch back one last time just for your memory, but you'll see that that particular problem did have a right endpoint of 4. So we're testing the endpoints just like the candidate's test says to. And then you can come up with those answers just as quickly on the TI-84. And won't go quite in depth with number 2021 because that seems like a long time ago, right? In fact, this was the first normal AP test, right? After the course and exam description was released in 2021. But maybe you remember problem 2, which again, not a guarantee, but oftentimes problem 2 on the AB exam is indeed a particle motion. Particle motion with AB is a little bit different than particle motion with BC. On AB, typically that particle is moving in a straight line, but in BC, that particle can be moving all over the place, as indicated in Chapter 9, Topic 6 of the course and exam description. But if you break apart this particular problem, once again, you've got two particles, P and Q, just like the problem that Vicki was describing that was 2 years, the senior to this one. Part A, find the positions of the particles at time 1. That's a numerical integral, once again. And so we're seeing those same skills in a different kind of problem, this time particle motion. Find the acceleration. Is the speed of the particle increasing or decreasing at time 1? Explain your reasoning. Well, we could be numerically calculating a derivative there, but you know what? I think we could also be looking at the plot of the graph of the function, right? I mean, a student could really do that one of two different ways, and I really love it when I get the opportunity to show both of these methods to my students as we are prepping. You could do this very problem with your students prior to the AP exam to kind of get them on board with that. And so really quickly, I'll just show you the part C here with I've got the TI-Nspire here all kind of queued up. And with that part C, well, there's two things. Let's go back here. I've got my velocity of particle P and my velocity of particle Q that I've stored. But this particular problem wanted to know about particle Q. Is particle Q speeding up, or is its speed increasing or decreasing? And so I have to compute the acceleration of particle Q at time 1. This here is just text. This is where the math box actually begins. And so I just compute another shift minus, evaluate it at 1. And oh, I don't have an answer yet. I guess I need an answer. There it is. Okay, I've got an answer. And then I do the same thing, except I evaluate just the velocity. So this guy right up here needs to be evaluated at time 1. And I get -1 for that result. And then I find that those two things have opposite signs. Therefore, moment of truth here, right? I know that the speed of the particle would be decreasing at time 1. Well, another way to think about this is if we think speed is the absolute value of velocity, which of course it is, we could just graph the absolute value of the velocity function of Q. And so this is just entered into the F1 menu, just like you could enter this into the TI-84 Y1 equal menu if you have V stored as Y1, let's say you had V stored as Y1, you could enter the absolute value in Y2 and you would generate this graph. And you can see that here at time 1, that speed is certainly decreasing. And so it reinforces those things that we just saw with the sign change. I think that becomes a really powerful tool for students when they can see multiple ways that the calculus is being presented to them. And so what we've done here is Again, I think I probably have typed more former AP exam questions on the operational tests for everyone in this webinar combined. So I don't want anybody to have to do that again. And so I have a document, several documents. This is the cover page of the rate in and rate out. So I took some of the past few years problems and I categorized them, whether they're calculator active or no calculator. Can you predict a trend there with the rate in and rate out problems, Vicki? In terms of calculator use, it seems
Yeah,
pretty
I
clear,
think you're
right?
going to use it.
I think so too. And some of those pictures might bring back some great memories for those of you that have taught for a while with bananas and toll plazas and escalators and fish ponds and so forth. But basically, there's the first question. I just retyped it, have some boxes for the students to work. And you can just have your students work on this. I do this as a free response roundup. I'm not going to go into great detail about the directions because you can find the directions in the links that we share. And basically students can kind of work individually for just a little bit, and then they group together for a longer period the first week. And over time, I wean them on the amount of time that they work as a group, to the point where about a week before the AP exam, they're 15 minutes just by themselves. And then what I really like to do is in that same document, I don't share this with the students, but in the document that you will have, so don't photocopy these pages. You don't want your students with the answers just yet, but you can put these on the board. And I have already the global mean for both A, B, and BC for that particular problem. So you don't have to hunt those down. And then why not? I put my school's mean right underneath there to let my students kind of know how far off we were from the global mean. And that's just part of the instructional planning report that you all have access to as audited AP calculus teachers. And I find that that's so valuable to me. I can find out where my strengths and weaknesses are as a teacher, and of course my students' strengths and weaknesses by how far apart these are. And sometimes students, especially if you find that you're over the global mean, your kids can really take a lot of pride in the fact that, you've got a good program and that you're really in their corner and whatnot. And if you're a little bit below the global mean with hard work and dedication, like you all, I know, are able to put in, you're going to find out that your scores are definitely going to go up. The longer you teach this course, it's going to happen. Ask anybody in this room and they'll tell you the same thing. And so,
All right,
yeah,
Tony, we're getting kind of tight on time here. So
yes, we are. I'm going to turn it, I guess, over to you if you've got anything else that you wanted to end with here,
yeah,
Vicki.
I want to make a quick plug for the brand new AP pre-calculus course. The official CED course and exam description document was released 6 days ago on March 1st. You can find it on AP Central. We are starting to have conversations about how Texas Instrument educators or instructors can help educators with materials. Look for some webinars this coming fall, so make sure you check the TI site for some possible help with the new AP pre-calculus course.
All
All
right.
right, Mike, it's all yours.
I'm going to send it over to you, Mike. I put the links to pretty much everything that I think we've shared. So you've got a chance to retrieve those now, hopefully. So,
Awesome.
Mike, I'm going to give you control.
Thank you. And while I'm sort of doing my wrap up here, I know that another quick plug. I believe Vicki and Tony, you guys are working on some material for this summer for TI, for some
Yes,
PD.
for some PD with the AP calculus, and then hopefully we'll start turning out some things for AP pre-calculus.
Awesome. So if you kind of like what you saw tonight, take a look at our website and look for summer workshops, and maybe that would be a great place to get some more information. All right, so as promised, we are giving away to one lucky winner tonight a TI Graphing Calculator, their choice. And tonight's lucky winner is Joanna Yarbo. So, Joanna, congratulations. We'll be reaching out to you over email in the next couple of days to get some more information from you about which graphing calculator you choose. So, start thinking about that. I do want to mention that there is a TI teacher community Facebook group that is just made up of just teachers. It's a private group, so if that's something that would interest you, I know that someone had mentioned earlier tonight There's a group that's specific to calculus, which is really neat, that's out there on Facebook. So just feel free to join any of those that you think would be applicable to you. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents that were used tonight. In case you're missing those for any reason, just hang tight. You should automatically get a follow-up email in a couple days, and that follow-up email will contain a link to the recording, which is going to be great to have, a link to the certificate, and a link for the documents as well. And if you're watching this on demand, copy that link into your favorite browser to receive your certificate. Post-webinar follow-up, if you need to get a hold of us for any reason, give us a call or send us an email, 1-800-TI-CARES or ti-cares@ti.com. And last but not least, when you leave the webinar tonight, a brief survey automatically appears in your browser. Your feedback really guides us as we plan future online events. This was something that was suggested in the past, and that's why we're having this now. So if you liked what you saw tonight and you want more of it, feel free to include that in your survey. If there's things that you think we need to be doing better, please let us know that as well. We'd love to hear your feedback. Huge thanks to Tony and Vicki for everything they put together tonight. Thanks so much to the two of you, and special thanks to everyone for joining us tonight.
Thank you, everybody.
Thanks, guys. We'll see you.
Have a great night, and we'll see you next week.